Hi guys, and welcome to Spring School on 319. We are so excited that you are joining us, Matrix. We are glad that you are tuning in. Kashifa and all our mindsetters, we want to give a big up and say hola, and we are so glad you are tuning in. As you can see, we've got a guest here today. This is Marara.
Hi guys, how are you? I'm a mindsetter now, aren't I?
Exactly. You're part of the team. And if you missed Marara, she was on the show a few weeks ago. But let's do a little recap. You're in grade 12, right?
Yes, I am. I'm in grade 12, and I go to Greenside High School.
Yeah, so big up to all the Greenside High guys,
eh?
Yeah.
You better be watching.
Yeah, you better be. So, hopefully you are tuning in so you can see Marara. Guys, if you do go to 4 Ways High, please let us know on the page. Just got to give you a quick little update on how to chat to us. Facebook.com/LearnExtra. You can also chat to us on Twitter @LearnExtra. And if you've been watching this week, you know that at the beginning of every show, we do the competition question and the challenge question. We'll be getting to that now with Tamlin. But what we want to do is I want to show you what is up for grabs today. Yes. But first of all, let's make sure that you guys all have your Spring School books out. If you haven't ordered your books, you can download them from our website, and I'll post that onto our Facebook and Twitter right now.
For free, guys. It's for free.
Exactly. Thank you, Marara. You can come again. So what you can win in today's challenge question are these 3 CDs. Marara, don't you want to hold them up and give a little... So what that is, this one is, let's have a look there. I think that says Electro Candy. So this is from Soul Candy, guys. Really cool. And then the next one is DJ What. What? And then we've got the Platinum Edition, which is Mikasa, and I know how much you guys dig Mikasa.
Everyone loves Mikasa.
Exactly. So now, if you guys are winning the challenge question, you've got to be part of the Mindset team, so you'll also be winning this awesome I'm a Mindsetter t-shirt, and as well as this Mathematics grade 12 textbook. But I don't want to take any more time away from Tamlin.
No, we all need maths.
Yeah,
more than
and learning,
competition.
right? Yeah, exactly. So I think without further ado, let's hand it over to Tamlin.
Tamlin,
take it away.
Thanks, guys. Thanks, and welcome, everybody. Hope you're all ready for a good lesson of trig. Feel a little bit out of it because I don't recognize any of those CDs, but what I can do is teach you maths.
That's the important bit, Tamlin.
That's the important bit. Yeah, no, those are all very different. All right, guys. What we're going to start off with today is having a look at our competition question. Okay, it's going to be posted on the Facebook, on the website, so have a look, go and see if you can give it a try. Just to quickly go over it, what we are asking of you is what is the value of the expression 2 cos squared 30 minus cos 60? Okay, those are the 3 possible answers. We've got 1 as the answer for A. Answer for B is 1.23, and the answer for C is 1.5. So guys, sit down, have a look through it. It's not too difficult, but let's see if you can get that answer correct. So all the best to you guys. Right. We are going to get started on my own little challenge question for you today. So this is what I want you to do. I'm going to put this question up for you guys, and what I'd like you to please do is write it down, and over the course of the show, when we have a break and you have a minute, I want you guys to try and work it out, okay? This is one of these questions where you just have to apply a little bit of logic, okay? A little bit of a process to it, and if you guys can work it out, I will be very impressed. So this is what the question is. I want you to determine the value of, I've got tan of 1 degree times by tan of 2 times by tan of 3, and so on all the way up to times by tan of 87, then times by 88, and finally times by tan of 89. Okay, I want to know what is the value of all of those values for tan multiplied together. So all the best. I hope you figure it out. It's not difficult, just a lot of logic you need to apply there. So think about it carefully. Right, grade 12s. Let's get going with the beginning part of this lesson, which is going right back to our Pythagoras type questions. As we've mentioned before, guys, your paper 2, where your trig will come up, your Pythagoras type question is very much to be expected as one of the first questions you're going to get in that exam. Okay, so let's have a look through this one. And I know you guys have practiced lots of them already, I'm quite sure. So let's see if we can figure out what this is asking us. We have got, in question 1, the diagram which is giving us the point P, which is the coordinates of 12 and 5. We have been told that my line of OT is perpendicular to the line of OP. PS and TR are both perpendicular to my x-axis. Okay, that's fine. So we know we've got right-angled triangles. And we have been told that angle POS is equal to alpha, and my distance from O to R is 7.5 units. Okay. All right, so this is quite an interesting one because we're actually working in two different quadrants here. We're working in quadrant 1 and quadrant 2, and there's two different right-angled triangles that we're working with. I'm sure you can see, just without having to actually look at the question just yet, having the point over here, having my value, the coordinates of 12 and 5, that actually is giving me quite a lot of information straight away, okay? Remember, in a coordinate point, the first coordinate is always your x value, the y coordinate is always your second value. So straight away, we know that we've got a 12 on our x-axis, and I have got a 5 on my y-axis, okay? That leaves me quite easily to find my length from O to P, and that is because it is the hypotenuse of that right-angled triangle. So very quickly, let's work out that hypotenuse. If I took 12 and I squared it, plus 5 squared, that's going to give me my distance from O to P squared. Okay, we've got 144, we've got 25, and that's equal to OP squared. 169 is OP squared, and remember with Pythagoras, we always finish off by square rooting. Okay, so that gives me my missing length over there of 13. So that's great because we've now actually filled in quite a lot of information already that I'm quite sure we obviously are going to use as the questions go along. Let's see what they're asking us as part of question A. They're asking us to determine the value of cos alpha. So here's my angle of alpha. We've just filled in my missing line of 13, so we've got all of that information over there. Now we're going to find the ratio of cos alpha. Cos alpha, remember, is always your ratio of your x over your r, or we could speak about it as your adjacent side over your hypotenuse. Okay, either one means the same thing. And in this particular triangle, my adjacent side is 12, and the hypotenuse is 13. So without having to do too much in terms of working out, we can see that the answer, or the ratio of cos alpha, is going to be my x over my r, which is 12 over 13. Okay, so first question done. Easy enough. Let's have a look at number 2. All right, angle TOR in terms of alpha. Now let's just spot it. Here's point T, there's O, and there's R. So we're looking for that angle over there. And they've said to us in terms of alpha. All right, as soon as they say that, what they are saying to you, grade 12s, is that your answer is going to have an alpha in it. Okay, if you're finding it in terms of alpha, that's what we're going to have something that includes an alpha. Okay, what have we got over here? Let's see. I can definitely see that I have got my x-axis, which is a straight line. I've got alpha. I then am adding 90 to it. And then we've got this angle at the end there, which completes the full 180 degrees. Okay, so in order to find this missing angle over here, which is what they're asking me to do, we are going to have to apply the theory of adjacent angles on a straight line. Okay, adjacent angles right next to each other on a straight line add up to 180. So to work out our angle here, we are going to say angle TOR will be equal to the full 180 degrees minus the 90 degrees that we know we've got in the middle, plus the alpha that we had on the other side. Okay, so therefore, if we just simplify that, angle TOR will equal to 180 minus 90, which will leave me with just 90. And a positive and a negative is going to make negative, and we'll have just alpha. So that's what we are sitting with now in terms of alpha for the angle of TOR. So this angle over here is now 90 minus alpha. Okay. Right. Those first two questions done. Let's have a look at the third part of it. They're asking us now for the length of OT. Let's just highlight my length of OT so we all know exactly where it is. We're looking for this length over here. Okay, that's my length that we do not know at this point. Okay, so let's take a careful look, grade 12s, at what we actually have over here. We've got a lot of information on this triangle in my first quadrant. We know all the sides. That's filled in quite a bit. In terms of the second triangle, what do we know? Bear in mind, we were told something in the beginning, that my length from O to R is 7.5 units. So let's fill that in. 7.5 units is going to have to go on my length from O to R. Now, I want to spot if you guys can see what I should be filling in there. Marara, let's see if we can get
Let's
you
put her on the
awake,
spot.
Let's
I like that. Let's put her on the spot, definitely.
What have I not filled in there?
Yeah.
And my clue to you is, what axis is that on? What x-axis is that on?
Shame. I think maybe I was making her work too hard on the page. Is that what I've been doing?
I couldn't concentrate.
Okay, let's have a look at it. Do you agree anything on this side of the x-axis is a negative?
Yes.
Okay, so when they talk about the distance of a line, okay, they are not going to specify positive or negative, okay?
'Cause
You've
the
got to
length,
be switched
right?
on enough to actually see that. We are working on the left-hand side of my x-axis, meaning that this is in fact a negative 7.5, okay? All right. Now what we have got over here, so that would get us to this point over here of negative 7.5. I have got, now let's see, we've got an angle of 90 minus theta. I've got this length of the 7.5 units in terms of a length, but that's it. It's not going to help me find that length from O to T to O. It's kind of, we're sitting stuck. So let's go back. Okay, so let's do this. If you are looking for a missing side, a pretty good starting point is let's take what we are looking for and put it over what we've got. This side over here, this is my hypotenuse, and the side that we have is my x side. Now, if I took that as a ratio, if I worked with the ratio of the x over the r, that would be working with the ratio of cos, okay? So let's say this. I'm going to take cos from my angle of 90 minus alpha. Remember, that was the angle that we're working from in our second quadrant. And it's equal to my x, which is a value of 7.5. If I'm talking about it as just a length, I'm going to leave it as positive. It's only if we are working with the actual coordinate that it would be negative. And I'm going to put it over my missing side, which is OT. That was the length that we were looking for. Okay. Sine of, if I've got cos of 90 minus alpha, okay, that we are dealing with a co-function. Okay, so there we need to be careful. If you've got cos of 90 minus alpha, that is going to change to sine of alpha, which is equal to 7.5 over OT. Okay, now that leaves me with still nothing that I can't actually solve for OT with what we're sitting with. But let's be clever here for a second. Sine of alpha, remember alpha was actually in my first quadrant. That was my first triangle, okay? And if it's just sine of alpha, do you guys agree we can actually get a ratio for sine of alpha? We can work out what that is. Sine of alpha is your opposite over your hypotenuse, which would be your 5 over your 13. So instead of working with just sine of alpha, we are going to work with, oh, I've just forgotten it. It is 5 over 13. So therefore, that's what we've got. 5 over 13 is equal to my length of 7.5 over OT. And what we can now do, guys, is we can cross-multiply this, okay? So I'm going to multiply my 5 with the length of OT. And we've got 7.5, which we are going to multiply with 13. So 7.5 times by 13. And we get 195 over 2. Okay, fine. 195 over 2. And what we can then just do is to get OT completely on its own, we're going to take 5, and we're going to divide the answer of 195 over 2 by 5. So we're going to take that answer, and we are going to divide it by 5, and it's going to give us 39 over 2, which, if we actually work it out as a decimal, would be 19.5. So the length from my O to my T is going to be 19.5 units. Okay. All right, so that was actually quite a nice Pythagoras question. It just took it to a slightly higher level in terms of what you can maybe sort of normally have seen. But again, it's a case of recognizing that if you had a sine of alpha, you actually had a value there, and recognizing that was the key to then obviously getting that correct. Okay, right. I hope you guys are all following us. I hope everybody's feeling comfy and ready to really get stuck into more trig, and I think we're going to take a short break. Is that correct?
Oh, ouch, Marara. She's pinching me.
Well,
Hey?
she asked me to. What's her name again?
Oh, gosh. I think, who was this? Anele, you naughty. Anele is telling Marara to pinch me. So there you go. I have been pinched indeed. Guys, before we go to break, I just want to say big up to Liberty. Thank you so much, guys, for making this show possible. We really, really do appreciate that, and we wanted to let you know. Also, before we go to break, guys, there are other ways to also enter the competition other than posting on our Facebook page, and this is how you do it. You can also email win@learnextra.co.za with your correct answer, or you can put the question, your answer of the question, in our pep text group, and our group code is LearnExtra, and you can SMS 083 448 8810. So get those answers coming in. We're going to go for a quick break, and we'll see you when we get back.
Guys.
Hi guys, and welcome back to Spring School Matrix. I hope that you are having such an awesome time. I think Marara and I and Tamlin are having an awesome one, right?
Great time.
We were just discussing this prize that we're giving away. See, we've got these 3 CDs, but in this Platinum Edition, which is Mikasa, there are 2 CDs, so that's 2. Let's see how everyone's maths is. DJ What, he's only 1 CD, but still. And then we've got this Electro Candy, which is given to us by Soul Candy, but this is 3 CDs.
That's
so
like 3, 2, 6 CDs.
6 CDs, right? And a T-shirt and a book, and it's
Guys,
pretty awesome.
You have to enter. Really, 6 CDs.
Yeah, no, guys, and also I just wanted to say that we have reached 19,000 thanks to you guys. We think that you guys rock, and we think that you guys are absolutely awesome. Big up to you guys watching, Sidonia, Kashifa, Anissa, Noxpedia. So glad that you are tuning in, and I think we're going to take a little less time away from Tamlin's teaching, and we're going to pass it back to her. But guys, if you do have any questions, please post them onto the page. This is the time to ask questions. There is no such thing as a silly question, only the question asked after the exam, because then what?
No time.
Then it's too late. Then it is too late.
Too late.
Chat to us on Facebook.com/LearnExtra, also on Twitter @LearnExtra. And now let's get on with the show. Tamlin, take it away.
Right, guys, let's have a look at some more identities. If you were watching a little bit earlier, we did quite a show on identities, where we practiced quite a few of them. So if you had watched that, I'm sure by now you're feeling pretty comfortable with them. But let's have a look at more of them. These, once again, are a sure thing in your exam. You will definitely get them, all right? The example that we're going to have a look at over here, just to point out to you, does not involve double and compound angles or double angles at this stage. So this would be sort of a more what you learned in grade 11 in terms of your reduction formula, and just how we use that reduction formula to prove a left-hand side equals a right-hand side. Please remember, if you are solving or if you are proving an identity, that's what your goal is. Please, you are proving that the left-hand side of your equation is equal to the right-hand side. You are treating them as 2 separate entities. You do not cross anything over the equal sign. That is really important to remember. Okay, so let's have a look and see what we've got.
Tamlin?
Yes.
Before we go on, can I ask you a quick question from Nombulelelo? And I think it's got to do with what we're talking about.
It's Pythagoras question.
Pythagoras question. So she wants to know, for the Pythagoras question, would she be penalized for using the sign rule? Because she got the same answer.
If she got the same answer, what I would say is this. If you got the same answer, that's great. The question I would have to ask with regards to that is how she got the answer if you had the angle of alpha, because you would need to know what that angle was. So what I would say to you is just, if you sometimes can apply the sign rule, and that's fine, watch your mark allocation. If the sum is only for 2 marks and you've kind of gone around and done this whole long sign rule, it's also a case of wasting a little bit of time, which you always just have to be careful of. With that question, you didn't know the size. You only knew the 90-degree angle. You didn't know what alpha was. So that would make me question how we got there without knowing what alpha was. So I'll go and have a look at it. I'm more than happy to go and double-check and see. But to answer the question, can you use the sign rule? If enough information is there and it's applicable, you can. But with a 90-degree triangle, you've got your opposite, your adjacent, your hypotenuse, and as a result, you can use your normal trig functions or trig ratios. So as a result, it just causes you to not waste any time.
It's simpler also.
It is simpler. Yeah, that's it. Okay.
Thank
So
you,
I hope that answers
Tamlin.
your question.
Hope that answers your question.
Yeah.
Okay. Let's have a look at this example over here where we are proving our left-hand side equal to our right-hand side. Okay. I have got sine of 90 plus x. I've got that multiplied by cos of x times by tan of negative x. Okay, so here's something to watch out for over here. We're going to just make a little mental note that we're going to have to be careful there. We are going to have to be careful over here as well. And, okay, we're also going to have to watch out for this, but in fact, we're not going to, well, it's just normal reduction formula there. We're not going to have to be quite as careful with that one. Let's see what we've got. Sine of 90 plus x. I really hope by now that the teachers have drummed it into you guys enough that if you are working with a 90 plus or a 90 minus, you are changing to your co-functions, okay? And that simply means that your ratio of sine theta is equal to cos of 90 minus theta and vice versa, okay? So if I've got 90 plus x, first things first, that's taking us into quadrant 2. Okay, now here's something you've got to watch out for. In quadrant 2, sine is positive. Okay, so we know sine is positive in quadrant 2. But here's the tricky thing. Because of the 90, sine changes to cos. Now this is where I know learners have a problem because suddenly everybody says, hang on, in quadrant 2, cos is negative. So now, is it positive or is it negative? Marara, do you ever have that problem?
Yes, I do.
Okay, it always takes the sign of what it was originally. Okay, so if sine is positive, even though the cofunction changes it to cos, it stays positive. Okay, so it's going to stay positive and it's going to change to cos x. Okay, we have then got cos x, which nothing's going to actually happen to that over there. Right, now we're sitting with tan of negative x, okay? Right, Marara, tell me, if we're working with a negative x, do you remember which quadrant we're in?
We're in the fourth quadrant.
Excellent, we're in the fourth quadrant, okay. So anytime we see that I'm working with a negative angle, we know that we are working in quadrant 4, okay? Which means that in quadrant 4, tan is negative, okay? So we have got a negative tan x. Right, and this is all over. I've got cos of 180 plus. If I look at my axis, 180 plus is in my third quadrant. And if we remember our cast diagram, the good old cast diagram, in our third quadrant, cos is negative. Okay, so that's going to also be a negative cos x. Okay, so what we've got on this left-hand side so far is cos x times by another cos x times by negative tan, and it's over negative cos x. Okay. This is one nice thing to spot with an identity such as this. Everything is being multiplied. And as long as there is a times between each one of your terms, you can cancel. Okay, there's no problem with that. As soon as there's a problem is where there's a plus or a minus separating your terms. And that's where you've always got to be very careful. Over here, we don't have to worry about that. We have everything being multiplied. So we can go ahead and cancel our cos x with our cos x, and in fact a negative over a negative will become positive. So those two have fallen away as well. That's now left me with a cos x multiplied by tan x. Now tan, when we're working with an identity, a worthwhile thing to do is always to change everything in terms of sine and cos. Why? Because then obviously you're working with like. Okay, everything is in the same thing. So I have got tan x, which I'm going to change to sine x over cos x. Okay. And with that, we can cancel top with bottom there, and we are left with sine x. Now let's just take one quick look at what we were supposed to prove, and we can see that we have done it. We have managed to prove that your left-hand side, all of that worked its way down to being just sine x, which is exactly what it was on the right-hand side. So please make sure you finish off with your statement that therefore your left-hand side is equal to your right-hand side. Okay. What's really nice about those trig identities is when you're proving them, you always know when you're right. So that's always a nice thing to know. Is when you've got it, and that's always a nice feeling. Okay. Right, what we're going to have a look at now is just a bit of interpretation on our trig graphs. Okay, what we have been given in this question, grade 12s, is we're given a trig graph, and we've been told that it represents the function of f of x, which is equal to sine 3x, okay? Please remember, if there is a number in front of your x or your theta, whatever that angle is, that represents the period of your graph, okay? Now what our period is how many repetitions of our graph do we have between 0 and 360, okay? Your normal period of a sine graph is always 360. Putting that 3 in front of it is saying that from 0 to 360, we are now going to have 3 repetitions of it. And as a result, what's happening is that your graph becomes squashed, okay? Everything happens earlier and sooner, and it happens more often, okay? So just to quickly give you a bit of background here, if the question said, and in fact I think that is exactly what the first question says, the period of f. All right, here is a fairly common mistake some people make. They say the period of f is 3, okay? And the reason you say that is because there's a 3 in front of that x over there. The period is how many degrees it takes to complete a full repetition of your graph, okay? So unfortunately, it is not 3, okay? If you had to think about a sine graph squashed into 3 degrees, that would be extremely small. So that's not what we're talking about. How many degrees does it take? So our normal period is 360 degrees of a sine graph. And what we do is we divide that 360 by the 3 repetitions that we would have, resulting in 120 degrees. That is then the period of your graph, okay? If I were to quickly have a look at it, if I've got 120, which is over here, okay, my normal, this over here is 1 full repetition of your sine graph, and it went from 0 to 120. So you can see that that was your period. That's how many degrees it took to complete 1 repetition, okay? All right, so that would be the answer to f. The period is equal to 120 degrees. Okay. From there, they've now said to us that we are going to write down the solutions for sine of 3x. Okay, that's the graph that we've got, where it's equal to -1 on the interval from -90 to 180. -90 is our lowest value on our x-axis, up to +180, which is our highest value on our x-axis, okay? So they're asking us, where is the function sine of 3x equal to -1, okay? What I want you to do is this. Take yourself a line, and I want you to draw it through the y-axis at -1. Okay, we can move that up slightly. There we go. Right. So where is it crossing the graph at the point where y is equal to -1? We have a point of intersection over there as well as over here. So where x is equal to -30, y is equal to -1. And where x was equal to +90, x was equal to, y was equal to -1. Okay. So the way we write our answer is we say x is an element. Okay. We're going to use our curly brackets like so, because what we're doing is we're not talking about a range of points. I'm talking about specific points. Okay. If I wanted to talk about a range of points from one point to another, we would use our interval notation, which is our square brackets and our round brackets. Okay. I'm not doing that here. I'm saying that I'm specifically talking about -30, and I'm specifically talking about 0.90. So therefore, in a curly bracket, we say that x is equal to -30 and 90. And we close that off. Okay. So again, don't fill those in with square or round brackets, because then what you are saying is that it's everything on the x-axis from -30 to 90, which obviously is not the case there. Okay. Right, that's that. Let's have a look at the next part of it. Okay, they're now saying to us, give the maximum value of h. Now, h is a new graph. We don't have this yet. Where h of x represents f of x minus 1. Okay. Grade 12, anytime we're taking a number and we're plussing or minusing a value onto your function, what that represents, please remember, is your vertical shift. Okay, so any value being added onto your function represents your vertical shift. Now in this case, the vertical shift is a -1, which essentially is saying that your entire graph is being moved 1 unit down, okay? So if I were to draw that, let's draw h of x and see what it would look like. This point over here has now moved 1 unit down. This point, which is at 1, has moved 1 unit down. This point has moved 1 unit down. 1 unit down, and 1 unit down, and so on. Okay, so if I were to actually redraw this, I'm just going to draw it on this side here. Let's try not to miss the points. Okay, that would be your new function. So the shape of the graph has not changed. Okay, nothing's changed in terms of your period, but what has changed is that the whole graph has been moved 1 unit down. So the question is asking us, what is the maximum value of h of x? So what's the highest point on my y-axis that we're going to be reaching? 0 is going to be your highest point. Okay, so your maximum value for this y graph function over here for h of x is going to be that y equals 0. Okay, and I hope everybody understands that. Your vertical shifts are the ones where if it says -1, it means -1. We move everything, we move all the points down 1 unit, okay? However, if it's a horizontal shift, if you just remember to quickly throw that in here just so we know. All right, let's say I've got a sine of theta plus 30, let's say. Okay, as soon as we're adding or subtracting a value onto your angle, that is in your horizontal shift. Now remember with that, your horizontal shift, your axis is moving underneath the graph, not the graph itself. So as a result, if it said plus 30, if you remember what happens, is it actually looks like your points are moving back 30. Okay, and as a result, everything will move minus 30 degrees to the left, and your graph will shift. Okay, if we have time, we'll give that one a try, and we'll practice a bit of it. I'm going to give you a quick break and catch your breath. I hope you guys are all working on that tan question that I asked you to have a look at. We'll go over it shortly.
Okay, guys, we're going to take a little break. The page is on fire. Hey, Monaka?
Blowing up.
Merara. Oh, because I was actually I was about to say, Monaka is on the page, and she's from Limpopo, and she says it is hot in Limpopo.
I think it's 33 today. Hey?
Yeah, I think they said it's highs of 34 here in Josie, guys, so let us know what the weather is looking like there, and keep cool, keep hydrated, make sure you're very well rested to study, and yeah, pretty much that. And also Kashifa's always on the page, and she said that spring school is almost over, and she's got a little sad crying face.
Aww.
I know, I feel exactly the same way. And also Sidonia is also pretty sad. And we were talking about there are 21 days left until finals. So it really is the final countdown. And talking about 21, this is the number that we really want to get our Facebook page to. We are 19,000, and we think that 21,000 isn't such a huge stretch.
No, it's the perfect number even.
Exactly.
The perfect age also.
That's exactly. We want to have our 21st birthday here on Mindset Learn by reaching 21,000. So get your friends to like facebook.com/Learn Extra to get them chatting to us. Also on Twitter @Learn Extra. What we're going to do is we're going to take a quick break, go and get yourself some water, get yourself some refreshments, and stay stuck to the couch. See you now. Hi guys, and welcome back. I hope you enjoyed the break as much as we did. It gave us a chance to have a look at the page, see what questions you were sending.
Yeah,
and to discuss a few things. We were talking about, I know Kashifa was crying, saying that she's sad that spring school's over.
Don't worry, we'll be back.
Exactly. So what we can tell you guys is don't forget that these shows repeat again in the evenings. I will be posting the schedules on the page so you can get those. We've also got Saturday schools. Yeah, we've got more coming. We've got Saturday schools for you guys, matrics, so don't think that this is the end. From next weekend, we've got Saturday schools and the weekend after, as well as exam school coming up. We will post those schedules on the page and tell you a little bit more about it later, so keep your eyes peeled. So now we've got a question from Quinton.
Quinton.
Yeah, you want to read it out?
Well, Quinton says he wants to know how to draw a trig graph using a calculator, a Casio calculator. Yes.
Tamlin?
Right. Let me show you. This obviously is quite a handy little trick to have. It saves quite a lot of time. So the other thing that's quite nice about it is that it can be used for trig functions, but you can also actually apply it to your hyperbolas and your parabolas. So yeah, it is worth actually knowing. So Quinton, thanks for asking that. Let's actually go through it and see how you can manage it. Just to point out to you grade 12s, if you struggle to see on the board in terms of the table, I'd really suggest that you take a pen and you write down the keys that I'm pressing on the calculator here, and the best thing to do is actually go and take your own calculator and practice it, okay? All right, I'm going to use the example that I've actually just put on the board, which was the sine of theta plus 30, okay? And let me illustrate to you using the calculator how we can plot the calculator as well as actually where those points would go, okay? Right, this is what we do to plot the points. The first thing we do is we press mode on our calculator. Okay, let's close that enclosure there. Right, okay. We press mode on our calculator, and what we see now is the three options. The one you are interested in is the 3 for table. So you've pressed mode, and you've pressed 3 for table. Okay, once you've done that, it brings up an f of x equals, which obviously we're very familiar with. That's what we normally refer our functions as, okay. We are going to type in exactly what we see over here, all right? And that is, we're going to say sine, bracket. Okay, no, we've already had a bracket. Sine, theta. Now, in this case, we're going to have to use the variable of x, and x is above your closed bracket sign over there. So to get to that x, you have to press alpha and x, okay? That's your sine of theta, and I've got plus 30, and I close my bracket. So we've typed in the equation exactly as you see it, as it is over there. And once you've done that, you press equals. Now, what it does is now it asks you, where do you want to start, okay? On my graph over here, the lowest value on our theta axis that we had was at negative 30. So that's where we're going to start. I'm going to start at negative 90, okay, negative 90. And once we've typed that in, we press equals, okay? Where do we want to end? The highest point we went to was positive 180. So we're going to type in 180, and we press equals, okay? The steps, what jumps are we going up in on our axis, okay? Can you see that each jump on my graph over here was 30 degrees, okay? Sometimes it's 90 degrees. In this case, we were going up in jumps of 30, so we're going to keep it as that, okay? So my jumps are 30, and we say equals. And as a result, it brings up your table, okay? And these all represent coordinate points. So we're saying at where x is negative 90, y is negative 0.866. Where x is negative 60, y is negative 0.5. Where x is negative 30, y is 0. Now let me show you that point over there. Where x was negative 30, so here's negative 30, y is 0. So can you see that this point over here, which was at 0, has now shifted to negative 30? And remember we said with your horizontal shift, the axis underneath the graph has moved forward 30 degrees. And as a result, it appears that all your points on your graph have moved back 30 degrees, okay? And so as a result, this was at 0, which has now shifted to negative 30. The one that was at positive 30 would then have shifted to 0. My point at at 60 would have moved to negative 30. Okay, so just to give you a very quick example, so those 3 points would have shifted 30 degrees to the left, okay? And that would be then how you can use your calculator, just to show you again, to find those points. And just to move yourself down the table, you can see you press your downwards arrow, and that then moves you all the way down through all the points on your axis and what the y value would be on each one. Okay, so as I say, it's definitely worthwhile knowing that. It I think helps you in your exams when you're needing to save a bit of time, that you can use that very handy little tool there. Okay, I'm sure everybody loves that tool.
Oh, that's
okay.
awesome.
Yeah, it is very cool.
Yeah, it's so cool.
Absolutely.
And it's quick also. That's the best part. You
Absolutely.
save time.
It does indeed. And stats is another section where your calculator becomes very handy. So I'm sure we're going to be dealing with that in the upcoming few lessons. And yeah, the calculator as far as stats goes is also quite handy. Okay. Right, let's finish off the question on the graphs. They've now asked us they've asked us to draw the graph of g of x. Now they're asking me to draw a new graph, which is 3 cos x, and that's at the interval between my negative 90 and my positive 180. If you want to use your calculator to plot the points, you can go ahead and do so. Okay, I'm not going to do them because we learn these points off by heart eventually, okay? If I have got a positive 3 in front of my cos. Okay, your maximum point is going up to starting at positive 3. Okay, do you notice that in front of my x, Marara, what do you see in front of that x over there?
There's a ratio.
Okay, and essentially there's actually an invisible 1 there, okay? So what that is saying to you is that as far as the period of this graph goes, it's a normal period from 0 to 360, and from 0 to 360 you will only get one cos graph, okay? So what we've got over here is our minimum and maximum point are changing, but my period is just normal, okay? Right, so for my cos graph, we are going to start up here at 3. That's our maximum point. We are then going to pass through at 90. I'm going to pass through 0. And at 180, we would go down at negative 3. As I say, if you use your calculator, you will find those points. And at here, I'm going to go down to 0 at negative 90. So this is what my cos graph will look like. On the positive side, and on the negative side, it will do that. Okay. Right, so that's what we're sitting with now as far as the cos graph. That's my g of x function. Okay. So they've asked us to sketch that, and that would be then your answer to it. The next part of it is actually asking us to, okay, we are using that sketch. Okay, so let's quickly just redraw it so we can apply the question. It was at 90 and negative 3. I hope you guys are all winning with your calculator and working those points out. Okay. Right. Okay, they asked us now this looks a little bit strange because they've given us this equation which has said sine of 3x over 3 minus cos x is equal to 0. Okay, now the first thing that's got to jump to your mind is that as it stands, neither of those two values for the sine function and the cos function, neither of them look like what we've been working with so far. Okay, so that's something to watch out for. What I know so far is that my f of x function was sine of 3x, okay, and my g of x function is 3 cos x. Okay, so my first problem here is that I am going to have to manipulate what they've given me to make it look like what we had in the beginning. I need to change that sine 3x over 3 to just sine 3x, and cos x, I need to change it to 3 cos x. Okay, so let's see how we'd go about doing that. I've got sine 3x, and it's over 3. And I've got minus cos x, which is equal to 0. Okay. If I'm working with a fraction, if one of my values is a fraction and the other one is not, it's always a good idea to balance them. And by balancing them, I mean take it and put it over 1. Whatever is not a fraction, put it over 1 so that everything is now balanced, okay? And now that it's balanced, you can now go ahead and say, well, do I have any kind of LCD, or can I find an LCD? And in this case, what we're going to do is make your LCD 3. All right, which means that this one over here just got multiplied by 1. This term got multiplied by 3, and so did the naught on the other side. And any rule of fractions, what you do to the bottom, you do to the top. Okay, sine of 3x multiplied by 1 is just sine of 3x. Cos x multiplied by 3 is going to become 3 cos x, and anything multiplied by 0 is just 0. And remember, with an equation, if you found a lowest common denominator, once you have applied your rule of what you did to the bottom, you do to the top, you can then drop your denominator. Okay, so therefore that is what we're sitting with, which in fact looks a lot more like what we were working with in the beginning, so this is looking good. And the next thing that would probably need to happen is let's move it over the equal sign. So sine of 3x has got to be equal to 3 cos x. So what are they actually asking me here? Where is the sine of 3x function equal to the 3 cos x function? So let's go back to our picture and see where we can find them being equal to each other. And obviously, whenever we're working with graphs being equal to each other, we are interested in points of intersection. Use the graphs. Okay, the question actually asks how many solutions. So they're not wanting us to go on a whole story. They just want to know how many solutions. How many points of intersection do we have here? All right, we can see that I have got 2 points of intersection, all right? And those 2 points of intersection were where the two graphs crossed each other, where they were equal to each other. So we've got 2 points of intersection. Okay. Okay, guys. I think we have one more question with regards to our trig graph. We do indeed. And this is asking us to use the graphs to solve where f of x times by g of x is less than naught. Marara, do you have a problem with these questions?
Yes, I do.
Do you find them tricky?
Yes.
Okay.
No, just be honest. Just be honest.
No, I do actually. I do.
They do, and I think the problem is that they look funny, okay? It looks odd. How are we supposed to find the f of x times the g of x is less than naught? But if we just think about it for a second, it's actually not that hard. So let me show you how this works. If something is less than naught, is that positive or is that negative?
It's negative.
It's negative. So we are looking for where the answer to the one graph multiplied by the other graph is negative, okay? Now, when we're multiplying values together, the only way that I would land up with a negative answer is if I had one value that was positive and one value that was negative, okay? That's the only way I would get an answer that is negative. So, I'm going to have to very quickly just redraw my cos graph again, because we want to compare them and look where the one times by the other is negative. Okay. Right, let me do this on the green graph for a minute. Everything that's above the x-axis, do you agree, is a positive y value? All the way along here, these are all positive y values, but then it goes below the x-axis, so they now become negative y values. And if I were to do the same on the sine function, all of these are positive values, but as soon as it goes below the x-axis, they become negative. It goes above again, so we've now got positive, and it dips below, so we've got negative, and again, it goes above to be positive. Okay. Right, what we can now do is, I'm going to see if I can use a fancy tool here. I'm going to use this tool, and I'm going to pull it along. Okay, this is what I want you guys to see. The reason I'm blocking the graph off is that I want you to just look at one portion of the graph at a time. Okay, so as I have at the moment, can you see that the green graph and the white graph are both positive, okay? A positive times by a positive is positive, so that is not going to help me. As I go along, let's pull our graph along, we're still working with positives and positives until we get to negative 60, because as we go past this point over here, I now have one value that's positive and one value that is negative. And a positive times by negative is negative. Okay, so everything from negative 60, and let's go along, I can see that I've got positive and I've got negative, so that's filling what we wanted. Positive and negative, and that still is the case all the way to there. Okay, so from negative 60 to naught, I had a positive and a negative, which is giving me negative. Okay. As we then continue to pull my shade along, I'm back to them both being positive. And if they're both positive, I'm not interested in that because I want them to be negative. So as we go along, they're still both positive until we hit that point over there. Because as we go along, I now have one that's positive and one that's negative, and that carries on up to negative 90. And from negative 90 to not negative 90, positive 90 to 120, they are both negative. So we're not interested. But as soon as we go beyond 120, I can then see again that I've got a positive and I've got a negative, and that continues to the end. Okay, so let's clarify what we've just done here. We very carefully looked along my x-axis from the left to the right, okay? And as we did that, a useful thing for you guys to just take your ruler, okay, and just put it vertically on your axis and run it along the x-axis, and you're looking for where one is above and one is below if you're wanting the answer to be negative, okay? If you wanted it to be positive, obviously in that case, you're looking for whether they're either both positive or both negative, okay? So where we had a positive and a negative was from my negative 30 to my negative 60 to naught. I then had from positive 60 to 90. And I had from 120 to 180. That was the third portion of my graph. Okay. So what is your answer going to be? My values for x, so solve for where f of x. So x is going to be an element. Okay. Here's the next thing to watch out for. They said less than, but they did not say equal to. Okay. So because we're not saying equal to, we are not including any point where there's a naught. Okay. Because we don't want it to be equal to naught. So I'm going from negative 60, but at negative 60, we're not going to include it because we're not including the values there. So I'm going to have a round bracket from negative 60, and that's going all the way to naught. And again, a round bracket. And then got a gap, and I pick it up again from positive 60, which went to positive 90. And then another gap, and then finally we went from a round bracket from 120 to 180. And that is how we interpret those questions of where the one times the other is less than naught. You're looking for where one is positive and one is negative. So I hope you can see that that's not actually too difficult in terms of working out. You just do need to know what to look for, and that's obviously always the important part.
Exactly. Okay.
Whoa.
So, guys, what I suggest is that if you don't understand what Tamlin is going over, please post onto our page and let us know where you're struggling so we can help you with those questions when we get back from this break that we're about to have. I just want to, Tamlin, we've got Munaka has put a set of trigonometry study hints, which Marara is about to read out. So,
Oh, wow.
So let's see what Munaka has to say.
She says, start simplifying complicated sides. Don't over-substitute the right-hand side on the study guides. I mean, on the right-hand side guide. Study your formulas. And then she says, simplify left-hand side when you start with right-hand side. And then she says, replace division line with division sign. Factorize, replace sine theta with x when cos theta with y.
So those are pretty good, right? So what we're going to do is that we're going to repost these. Munaka, thank you for these wise words of wisdom. If any of you guys have study hints like this or study tips, please post them onto our page. Maybe it's even an inspiring quote, because guys, you've got 21 days left. Let's get this going. The final countdown has begun, and we'll see you now after the break. Hi guys, and welcome back to Spring School. We're having such an awesome time. The competition is now closed. So hopefully you got your correct answers in, and we will be announcing the winner at the end of the show. Yeah, that's pretty awesome. Yeah. So how have you felt being on the show today?
That last question, yay!
Oh, no.
No, but why?
Ooh, it's like overwhelming. It's a lot.
I think what we should do, guys, is that we should carry on. If you do have any questions, Arara as well, you keep those questions in your head for later. And we will be going over the questions in the last 15 minutes of the show. But I think before we take away any time from you guys, get comfy on your couch, maybe jump up and get that energy up. Okay? And water. Water is very important, especially because today it is very hot, and it's good to keep those energy levels up and keep hydrated. So, Tamlin, I think what we're going to do is we're going to go over your question, right?
Yes, I think let's do that, and then I'm going to deal with another question which is obviously very common in your paper. But let's have a look at that one that I asked you guys to have a look at. Let's see if you got it right for me. Okay. We asked you to simplify or find the value of tan of 1 times tan of 2 times tan of 3 all the way up to tan of 89. Okay. So this is what we wanted you to spot. If I'm sitting with tan of 1, that's essentially the same as saying sine 1 over cos 1. Okay. Now let's work. We're actually going to work from the outside values in. Okay. And the reason why I'm going to do that is this. Remember in trig, something to always watch out for is that if you've got two values that add up to 90, you have a very good chance of them actually cancelling or being equal to each other, and that's what we want you to spot over here. Okay. So I've got tan of 1, and I'm going to multiply it by tan of 89. Now tan of 89 is going to be sine 89 over cos 89. Okay, now using your cofunctions, the rule of cofunctions says this: sine of theta is always equal to cos of 90 minus theta. Okay, so if I had sine of 1, that's equal to cos of 90 minus 1, which is 89. Okay, so that shows you that we're working with co-functions over here. So this is what I want you to do. Leave your sine of 1 and your cos of 1 as they are for now. And let's change this. Sine of 89 could be changed using co-functions to cos of 1. And cos of 89 could change to sine of 1. Now, if we've got everything in that form over there, the sines would cancel and the coses would cancel. So what we've just worked out is that the very first term and the very last term cancelled each other out. Would that happen with the second term and the second last term? If I had tan of 2 and I had tan of 88, do you guys agree the same process would apply? Tan of 2, let's do it one more time. I would then have sine of 2 over cos of 2 multiplied by sine of 88 over cos of 88. And if we use our rules of cofunctions, let's leave our sine of 2 and cos of 2 as they are. Okay. Sine of 88 can be written as cos of 2 because they are cofunctions. And cos of 88 can be written as sine of 2. And once again, they would cancel. So I hope you're starting to spot the pattern. What's going to happen is that all the terms from the outside in are going to cancel, cancel, cancel until you reach the value of tan 45. Okay, that's your middle term over there. That's not going to cancel with anything. So everything has cancelled out, leaving you with tan of 45, and your value of tan of 45 is 1. Okay, and I definitely know Quinton got it right, so that's a well done to you, Quinton, and I'm not sure who else managed to get that
I think Cindy also got it right, so well done, Cindy. Big up.
Awesome, well done. That really is showing that you're thinking and that you really are just applying the rules beyond just what's on at face value. So nice work, well done for that. Okay, guys, let's go back to our, let's just get our page, to our question involving also a bit of Pythagoras once again, okay? I know I've said it before, grade 12s, but these questions are very common and they are most certainly to be expected. So please get used to practicing them and see them. Just, make sure that you are very familiar with these questions. What they have asked us is sine of 61 degrees is equal to the root of p, and we have to determine the following, okay? As soon as you get this type of question, and the way you can typically recognize it is that you'll have sine, cos, or tan of a given angle, and you equal to a letter. And normally it's an M or a P or a T. I know you guys all know what I'm talking about. So that's the kind of question we're talking about here. Generally, I would say a good place to start, grade 12s, is start by drawing yourself a diagram, okay? And by a diagram, I mean 61 degrees is obviously in your first quadrant, so we're working in quadrant 1, okay? And if I were to draw a right-angled triangle into quadrant 1, like so, as a ratio, that's root p over 1. So sine is always your ratio of your y over your r. So root p is going to have to be on my y-axis, and r is going to be on that axis over there, your hypotenuse, leaving us with the x-axis to solve for, okay? And just normal Pythagoras is going to get applied. When we have the hypotenuse, we typically subtract the y side from the hypotenuse. So 1 squared minus the root of p squared, and that's going to leave me with my side of x, which is being squared. And just make sure that we always write our Pythagorean. Okay. Okay, so that gives me a 1. If I've got the square root of p that is being squared, the root falls away, and we're left with just p, and it's equal to x squared. And to get rid of our squared, we are going to square root it. So I've got 1 minus p is equal to x. And in fact, just always remember that it's always a positive or a negative. We have to decide which one it's going to be. And in this case, because we're working on our positive x-axis, it's positive 1 root of 1 minus p. Okay. That kind of sets us up for the rest of the question. So once you've got that there, the rest of it should be a case of just simplifying the numbers all down to 61. And then once you've got that, you can read your answers off the diagram. So that's the idea. We are trying to now work out in terms of p the value of sine of 241. So the first thing that jumps into my mind here is 241 is in my quadrant 3. Okay, quadrant 3 we can speak about as 180 plus whatever angle we're working with. Now remember, 61 is our golden number here. Okay, so we're working with 61. So let's test this. If I took, let's get out of our mode. Okay, let's just say mode. And to go back to your calculator, just so you guys know, we've pressed mode and 1 again. So please don't sit there stuck on table mode for the rest of your exam if you don't know how to get out of it, okay? We're wanting to say 180, and I'm plussing 61, okay? 241, that's exactly what we wanted, okay? We had a suspicion that would work, okay? So sine of, I'm going to change this to 180 plus 61. Now 180 plus is quadrant 3, and that means that sine is negative. So we've got negative sine of 61. In terms of what that will give me on my diagram, sine of 61 we know is the square root of p, and all that's different here is that there is a negative in front of it. So therefore my solution for the first one will be the negative root p. Okay, so that was our first answer, which we managed to do. Let's have a look at the next one. Still working with the same triangle, the same values. We're going to quickly just not lose our place here. So we had our root p here, we had 1 here, and we had 1 minus p there. Okay, and 61 as the reference angle. Now they're asking us for just cos 61. So they're not asking me to manipulate the angle because they've already given me the angle. They just want us to give them the ratio of cos. Now it's a question like this where I say, haha, this is exactly where you need to use that diagram, because if you didn't have it, it becomes a lot more tricky. So have the diagram. Always make sure you draw that diagram. 61 is here. Cos is the ratio of your x over your r, or your adjacent over your hypotenuse. So therefore, we have got the square root of 1 minus p. It is over 1. You don't have to write that. I think we all know that that would be assumed. So that would be the ratio of cos of 61, which you guys can see is so easy with that diagram in front of you. So you know what to do. Now they start getting a little bit more tricky, because now what they're asking us for is cos of 122. Okay. Remember, we've got to stick to our goal, and we've got to keep going back to that angle of 61. So let's think about it. 122. Is anybody seeing the connection between 61 and 122? Marara, are we seeing it? What do you see?
That it's double.
It's double, exactly. So I have got cos of 2 times 61, which is a double angle. Okay, so here what we want you to do is to now apply your double angle identities. Okay, cos is always the tricky one, and the reason why is because there's three identities that you have to choose from. Okay, in an example like this, guys, it actually doesn't matter. Okay, it really is not a problem which one you choose. When we're dealing with double angles in identities, where we're proving left hand side equals right hand side, that's where it's a little bit more important as to which one of the three you choose. Okay, so let's see. I think we should choose the 2 cos squared 61 minus 1. Okay, and let's see what we've got. Now in the previous question, we actually just worked out what cos of 61 was, and it was 1 minus p, and it is being squared, and we've got minus 1. Okay, so if I square my root, I'll end up with just 1 minus p, and I've got my minus 1. And it's a case, obviously, now of just tidying it up. So I've got 2, I've got negative 2p, and I've got a minus 1. And 2 minus 1 is 1 minus 2p. Okay, so that gave us the answer, which, okay, so what we did was we just used our theory. We knew it was a double angle. And from there, we just substituted in the ratios that we already had from the diagram. Okay. And this is a nice one. Okay, us teachers always like one that's just going to make you think just a little bit harder. So let's have a look and see what we've got. Cos of 73, cos of 15, plus sine of 73, sine of 15. I really hope you recognize just from what you've got what you're dealing with there. So Marara, can I ask, what are you working with over there?
We have a cofunction, and we have, what's that? Compound angle.
Compound angle, that's the word I'm looking for. Compound angle, absolutely. This is an expanded form of your compound angle, so we're going to reduce it, okay? Remember, guys, if you've got your cos together and your sine together, that's your cos compound angle. Okay, it's when they're mixing up your sine and your cos. That's when you know that you've got your sine compound angle.
Tamlin?
Yes.
What we're going to do is we're going to go to a break, which gives everyone a bit of time to breathe and go and do what you need to do. I think jumping jacks are the best. That's what we do during our breaks. Marada and I are doing jumping jacks.
Jump.
Exactly. Okay, I have to do a shout out to Tiani, because Tiani's upset that I never ever mention them, and I think that it's very important to mention the mindsetters that are always on the page, that are always inspiring, always helping other mindsetters out, and we love that.
Yeah, he's a mindset just like us.
Exactly. And what we do, try and tell the mindset, is that this page is not just for us, it is also for you guys. It is a community. This page is ours.
It's a study group, guys.
Exactly. Also, Precious, big shout out to you. What we're going to do is we're going to take a little break, and when we get back, we'll be doing more and more learning. See you now. Hi guys, and welcome back. I've got to do this quickly, but I have to read this out. Lundiwe, thank you so much for your inspirational quote. And what she says is, our biggest struggle will be our biggest success. So let's strive for the best, guys, and our exams will be doing nothing but smiling. Spring school rocks. Thank you so much, Mindsetter, for that inspirational quote. Now, without further ado, I'm going to hand over quick to Tamlin. We do have the winner of our challenge question, so hold on to those seats, guys. Could it be you? Could it be you? Tamlin, take it away.
Thanks, guys. Right, let's quickly finish this question that we were busy on, and then we're going to go into a little quick 3D triangle question. We said that we had a compound angle and we reduced it. So if I've got cos 73, cos of 15, plus sine of 73, sine of 15, we reduce that down to cos of 73 minus 15. That's just your formulas, guys, so go and learn those, please. And that gives you 58. Now, I'm sure you guys are sitting with this 58 and thinking, that's not a double angle, it's not a compound angle, it's not a compound angle with special angles, so where does this 58 fit in the whole diagram, okay? Remember that if you've got a 90 and you've got a 61, you do have a third angle in the triangle, okay? It's kind of this little lost soul sitting at the top there, which we don't always think about. And in this particular triangle, it's 29, okay? Now, 58 is actually twice of 59, of 29. And that is then where we're going to get the whole connection from. So what we say is that cos of 58 is cos of 2 of 29, and we use the double angle identities, and we just substitute in from the formula, working from the reference angle of 29 and not 61. Okay, so if you're in a stuck position and you're kind of working with a number that's not fitting in anywhere, don't forget that you do actually have a third angle in that triangle, which is often quite useful. Right, let's get on to this quick question over here. We're going to just jump through a few. Unfortunately, we don't always get to all of them. And I want to talk about this trig triangle. Okay. This is what the question has basically said. We've got a birthday card, and this birthday card has been opened and read, and it's sitting on the table at an open angle of 90 degrees. So we've got a 90-degree angle sitting on our triangle over there. They've told us that we've got a ribbon which is tying the two sides of my card together at the halfway mark. So each of those points is the halfway mark. They've told me that the short side of my triangle is x, and they've given me the fact that the long side is 2y, all right? What they're asking me to find, or they're asking me to prove, is that cos of angle GCH is going to be that angle there. They're wanting us to prove that it's y squared over x squared plus y squared. Right, this is what we need to do. I am going to start by identifying the triangle that it is that we need to work in. And if I've got that side over there, and I've got this side over here, if I connect those two sides together, that would give us this triangle that we obviously, where the angle that we're looking for comes from. So there's the triangle, all right? Now, they obviously told me that if the whole length from C to F was 2y, these have been divided in half, which means that I obviously have got y. Half of 2y is going to be just y. So let's take that out so it doesn't get confusing. And this length over here is just y. Okay, let's see over there if that's going to help me. Y and y. Okay. that gives me, let's see what else we've got. I'm also going to draw a line connecting that side over there. The reason why is, let's fill in what we've got. I know that that length is x, and I know this length is x. I knew that that was y. I know that this is y. This length on my triangle is also going to be x, because the top and the bottom of a card are always equal in length. And what we are looking for is, okay, so this is what we need to do, guys. We need to work out what the length of GC is. And can you see that in a card, if I've got a 90-degree angle, we've got Pythagoras. So my length from G to C is going to be x squared plus y squared. Okay, I've done Pythagoras. And if I square root that, it'll be the square root of x squared plus y squared. Okay. I have got my other side, which is going to be exactly the same thing. The other side of my card, my C to H, is going to be exactly the same thing. It's going to be the square root of x squared plus y squared. Okay. I'm now needing to know what the length of that side over there is, and it's going to match exactly the same as what I have over there. Where again, because there's a 90-degree angle, we're going to use Pythagoras. So my length from A to E is going to be x squared plus x squared square rooted. So therefore we're going to have 2x squared square rooted, which means that the 2 will be a root, but the x can be just x because we're square rooting it. Okay. Right, so this is what we have got. We've got our triangle. We have got our triangle, CGH. This length of my triangle is x squared plus y squared. This length over here is x squared plus y squared. And down below here is 2 root x. Okay. And what we are looking for is the angle in the middle over there. All right. You've got 3 sides of your triangle. You have no angles. So what you need to do, which rule do we use to apply? How do we work out what our angle is going to be? If you're sitting with no angles and 3 sides, your rule you need to use is your cos rule. Okay? So the cos rule is what we're needing to apply here. And in fact, there was a slight clue there because they had a cos there already anyway. And that's what we need to do. So unfortunately, I don't think I'm going to get time to go through the whole question, but what you're going to have to do is substitute in, work out little c squared is equal to g squared plus h squared minus 2gh cos of angle C that we are looking for. That's the hard part of that question done, grade 12s. Now that you've got that all under control, the case is that you need to substitute each of the sides that we got in the previous working out into your cos rule and very carefully work your way through the calculations of it until you land up solving for your angle, which is y squared over x squared plus y squared. I want you guys to please go ahead and try that. What we can do is I can post all of that working out on the website for you so you can go and check it. But I don't want to leave us short of time to check the competition question. So let's have a look.
And we actually know who the winner is as well, Tamlin.
Fantastic.
So yeah,
Fantastic.
so winner, we know who you are. We will be announcing it after Tamlin has gone through the question.
Okay, wonderful. Okay, what we all, I'm sure you guys probably had a look at, was using special angles to simplify this question over here. And we can go about doing that, but then I want to show you a small trick after that if it wasn't a special angle. Okay. If we've got 2 cos squared 30, I've got 2 and I've got cos squared 30. Let's just confirm our cos 30 is root 3 over 2. Okay. So we've got root 3 over 2, which is being squared, minus cos of 60, which is a half. Okay, and let's see what we've got here. So that if I square my root 3, we're going to get just 3. And if I square my 2, we're going to land up with a 4. We're going to land up with a 4, and that's minus a half. So let's see, if I cancel my 2 with my 4, I'm going to be left with 2 down below here. So we're sitting with 3 over 2 minus a half. Now 3 over 2 is the same as 1 and a half. And 1 and a half minus a half is leaving us with just 1. Okay. So if you guys did get 1 as the solution to that question, well done. That was correct. I'll let Indy quickly announce who the winner is, and then once you've done that, I wouldn't mind just showing you a quick twist to that tail.
Fantastic. I wish that the producer could put in a little drum roll here.
I can do it.
And the winner is Munaka. I couldn't believe it when her name came up, but Munaka,
Yeah.
it is a true story. You have, you've won the competition. Fantastic. You got the correct answer, and you obviously, she sent through so many, I think texts and whatever.
Text,
So,
messages, inspiration.
Exactly. So you are the winner, Munaka. Congratulations. Please won't you email us your postal address and your t-shirt size to win@learnextra.co.za. So congratulations to you, and we couldn't think of a better mindset to win this prize for today. So you've won a t-shirt, this awesome mathematics book, and
6 CDs.
and okay, well, it's 3, but it's 6, right? Yeah,
6.
6 CDs. So you're gonna have enough music for the rest of the year. Mindset, I think. Tamlin, let's see what this twist is all about.
Right, what would we do with this question if it wasn't special angles? Okay, special angles is always great because we know what those are. But let's say I had an example like this. I've got exactly what we had before, but instead of 30 and 60, I've replaced it with 25 and 50. Okay, so that leaves us with a bit more of a challenge because now we need to just use identities. We can't use special angles anymore. So what I would hope for you guys to realize is that, first of all, angle of 50 degrees is twice the size of angle 25. So I've got cos squared 25 minus, and I'm going to rather write this as cos 225. Okay. Now, let me take this cos 225, and I'm going to use the identity for cos, and I'm going to use the sine identity. So sine 2 sine squared 25. You'll see in a second why I chose the sine identity, and unless you already have seen, I've got a minus, and I've got a plus, and I've got sine squared 25. Right, if I've got 2 sine squared 25 plus 2 cos squared 25, if I took out 2 as a common factor, that would leave me with cos squared 25 plus sine squared 25. And any time I'm working with a cos squared theta plus sine squared theta, the identity to that should always be 1. Okay, so what we've got, a cos squared 25 plus a sine squared 25, and that works out to be 1. And we've still got a minus 1 that we had over there. So we had 2 minus 1, which still got us the answer of 1. So that's just showing you that it doesn't have to be special angles. You can apply your rules with funny other angles that are not actually special angles. Guys, I hope you learned lots today. I hope you've got lots of inspiration to go and do lots of practice. And I look forward to seeing you guys really soon.
Yeah, guys, it was so amazing. Let me just tell you, Londiwe, she says our biggest struggle will be our biggest success, so let's strive for the best, guys, and after our exams we'll be doing nothing but smiling, which is awesome. Thank you for your inspirational quotes. Thank you so much for helping other mindsetters out. Thank you, Marara, for joining us.
I had a lot of fun.
Oh, good. I'm so glad. Don't forget, guys, that the repeats are on at 4:30 today of this show. If you're watching the repeat, well, then good on you. That's awesome. We've still got 2 more days, I think, for spring
Even
school.
Saturday.
Also Saturday, we've got the
Saturday.
repeats. We've got exam school coming up. Always check our Facebook page for updates and what to do. And if you need help, facebook.com/learnextra. Have such an awesome day, guys. Don't forget that there is another live show happening later, so tune in and let's learn more. Let's learn extra. Bye, guys.
Bye.